Thank you, sir. Okay, yeah, we are. Good afternoon, everyone. Um, we are back to the geography session. Uh, let's pick up where we left off. We had earlier covered in the earlier. Oh, sorry. Yeah, in the earlier sessions, we had covered yesterday what we had really studied was the comparative study of the planets. We have compared and contrasted the planets on various aspects like their densities and rotational speeds and their temperatures, their tilts, including the size and density and everything. That should be enough. There is no need, once again, like one of my students pointed out, usually such questions aren't asked. You are not asked to go so deep, but like I said, I do not like to discount anything when it comes to UPSC. UPSC tends to ask you questions from here and there. So if it was comparing planets on the basis of size and density, there's no saying what it might want to compare for the next time. So we've covered that part as well. Okay. Today we are going to try to see all the physical aspects of Earth, including its latitude, longitude, tilt, and hopefully the local time and standard time related to it. Okay. Here we go. So, Earth is 4.6 billion years ago. It was formed with the rest of the planets, formed a little later among all the planets, because the inner planets were formed after the outer planets. So, once again, but then this is the actual timeline 4.6 billion years ago. The shape of the Earth is not exactly spherical. Okay. See, ideally, all the planets are round because of the gravity. The gravity tends to pull from the core because that is where most of the mass is. So the gravity tends to pull from all directions, and hence, usually, the bodies are a little, most of the celestial bodies are a little rounded. Okay. That's the general logic. Apart from the fact, and then apart from that fact, let's understand the motion of the Earth. Earth is a little Earth rotates around itself. Okay, it has a rotational motion around itself. Now, while it rotates around its axis, what happens is that the Earth does not rotate at the same speed at all points. Okay, it rotates faster at the equator, and absolutely zero rotation at the poles. Okay, and since the poles have zero rotation, what happens is that the Earth bulges at the equator and it is flatter at the poles. Okay, because of the centrifugal force, and this particular shape is called as spheroid or oblate ellipsoid, oblate spheroid, or geoid. Okay. These are very technical terms to describe the shape of the Earth. In layman terms, Earth santre ki tarah dikhta hai. Okay, bulging in the santra, bulging in the middle, and flat at the poles. Okay, that is how you. But that is true, right? It looks a little bit like an orange. Um, and so the question that is usually asked over it is, which is the larger circumference, the equatorial or the polar circumference? You should know it is the equatorial circumference. It is because it is due to the centrifugal force and the rotation of the Earth. Okay, the Coriolis force also exists because of this, because of the rotational motion, and that is how it works. Okay. Apart from now, since we are discussing the motion of the Earth, it has two types of motions usually that we are concerned with. The third type of motion, the precession of axis, is not really all that important, but rotation and revolution are two important motions. Okay. So let's consider the rotational motion. Earth rotates about or spins about its own axis, and we call that a rotation. Okay. One entire spin about its own axis is completed within 24 hours, something less than 24 hours, 23 hours and 56 minutes. Okay. 57 minutes. Okay, 3 minutes lesser to 24 hours. Okay, so we say it rotates from the west to east direction, counterclockwise direction, and it is because of this motion that the Earth has night and day. All right, the half the part of the Earth which faces the sun experiences daylight, and half the part of the Earth which is in the shadow of the sun experiences nighttime. Okay, so we say exactly half of the Earth goes through daytime and the other half goes through nighttime. All right. Okay. Apart from that, there is another motion that the Earth has, and this is basically what causes day and night. All right. Then there is another motion which is called as revolution. Okay, revolution is that the Earth rotates about itself, and meanwhile it also completes a revolution in an elliptical orbit around the sun. Okay, for that it takes the period it takes for that is 365.25 days. These 0.25 days is important. Technically, we consider a year to be only 365 days. Okay, and we consider the time taken for the Earth to complete an entire revolution around the sun to be a year. Okay, and that is what this is what we call as a year. The 0.25 days gets added over 4 years and forms a leap year and gives us that extra day on 29th February. And that's what we call it as a leap year. Okay. So these two motions are available. One, the rotation causes day and night, and the revolution causes the formation or the occurrence of a year. Okay. Now we have one more aspect of the earth that we have to consider, the fact that the earth is tilted. Okay. The earth is not straight, the earth is tilted on its axis. The tilt is for 23.5 degrees to the vertical. So if this is the vertical, the earth is tilted in a vertical fashion for 23.5 degrees. And if you consider the elliptical orbit is the orbit around which in which the earth goes around the sun, then it is at 66.5 degrees to the elliptical orbit. Okay, that is the tilt of the earth. Now this tilt of the earth makes the earth extremely habitable. Okay, and it gives you that various seasons and the fact that there are varying lengths of day and night on the earth. These are the these characteristics of the earth are because of the tilt of the earth. Okay, so let's imagine what happens if there was no tilt of the earth at all. If there was no tilt of the earth at all, then what would have happened is that the earth would have remained as very straight. And for 365 days a year and 12 hours a day, one part of the earth would have gotten all the sunlight at exactly 90 degrees at all latitudes, okay, including the poles. That is where the sunlight would have reached at all latitudes at exactly 90 degrees. So overhead sun on exactly half the hemisphere for 12 hours, and then the earth would have turned around and overhead sun for the rest of the and 12 hours of night time for the rest of the earth. Okay, so we are saying exactly half the earth would have received 12 for 12 hours exactly, it would have received overhead sun, and then for the next 12 hours the other part would have gone in complete darkness. Okay, and this is so obviously we would not have had any seasons, and the duration of the day and night would have been 12 hours exactly at all days of the year. Okay, on all days of the year. But that doesn't happen to us. Thankfully, the earth was tilted, okay, and tilted for 23.5 degrees. No, you have no idea. I love seasons. I cannot have overhead sun for 12 hours a day. Okay, so here we are saying that the earth is tilted, and because the earth is tilted, the sun's rays do not fall at all latitudes on the earth at exactly 90 degrees. Okay, there is only a section of the earth on which the sun's rays are received at 90 degrees, or straight overhead sun is received. For the rest of the earth, the sun rays are received in a slanting fashion at lower angles. Okay, so what we are essentially saying is, let's see. Say, suppose this is the earth. Okay, I love zoom. So, and this is the equator. Okay, and these are those two, Tropic of Cancer and Tropic of Capricorn. Okay, this is your Tropic of Cancer. Oh, acha, ठीक है. And this is the Tropic of Capricorn. Okay, this is the Tropic of Capricorn, and this is the Tropic of Cancer. All right. So we are saying only within this tropics, only within these tropics, this tropical region, correct? The tropical region is the sun's rays received in an overhead fashion at 90 degrees. Okay. So we are saying that, and that also not at all times in the year. We say at different latitudes देखा बच्चे भी चले गए। हाँ तो ओके, अभी अभी ठीक है, अभी वी आर ऑन। ओके, थैंक यू। प्राधान्य। इट्स नॉट वर्किंग। चलेगा। So, we are back online. Yeah, we are. So we say that the tilt of the Earth is responsible. If the Earth wasn't tilted, then we would have not had the variations that we see in the season or the varying lengths of day and night during various times of the year. Okay, so varying lengths of day and night meaning, during winters how the daylight is shorter, during summers the daylight is longer, and then if you go to different latitudes, the daylight varies even further. So if you're closer to the equator, the daytime and nighttime are usually divided into 12 hours of daytime and 12 hours of nighttime. Okay. But as and how you go farther away from the equator, you go towards the poles. The length of the daytime and nighttime during various seasons keeps on increasing or decreasing depending upon the season. So if you're looking at say summers, then the daytime keeps on increasing as and how you go towards the poles. Okay, correct, absolutely. And during the winters, the daytime keeps on decreasing as and how you go towards the poles. Okay, so this varying length of day and night, or the fact that we do have seasons, that there is a certain period during the year when the temperatures start to rise, and hence you feel the heat starts to rise, and hence the temperature rises. This is also due to the tilt of the earth. Okay, and now let's understand what is really the phenomenon that is really causing this. Okay, we have discussed that there is a tilt. We have discussed the effect of that tilt, and now let's go into the process of it. Okay, why that tilt makes these things possible. All right. So this is the reason. What we call as the apparent movement or the apparent motion of the sun. Okay. Once again, the key word is apparent. Okay. Apparent motion of the sun meaning that it appears like the sun is moving. Okay, we say that the sun is exactly 90 degrees between only within the tropics. Okay, beyond the tropics the sun gives slanting sunshine. Okay, slanting sun rays. So and it is not like even within the tropics the sun is 90 degrees throughout the year. Okay, it is exactly overhead at different latitudes at different times of the year. All right. Okay, so during this entire year what the sun is basically doing is that it is moving up and down within these tropics. Okay, for the entire calendar year the sun keeps moving among these various latitudes within the tropics, being exactly overhead the tropic of Cancer once a year, and exactly overhead the tropic of Capricorn once a year. Okay, and this is the motion that plots the, or rather tracks the motion of the sun. This is the diagram that plots that motion of the sun. Okay, it is called as apparent because it is not really the sun that moves, it is the earth that moves. But we are human beings, we study everything with reference to the earth. So obviously to us it is the sun that is moving. So we call that as the apparent motion of the sun. Okay, okay. So mark this motion now. In this particular diagram, you can clearly see, I hope this is visible. Yeah. In this particular diagram, we can clearly see that the upper line, wait a second, let's go and do this. Okay, this is what we are plotting. Okay, we say that at exactly 21st March the sun is on the equator. Okay, and so that we call as the spring equinox. Okay, it is called as the spring equinox or the vernal equinox. All right, after the spring, vernal is a adjective for spring. So we say the spring equinox or the vernal equinox occurs on March 21st. Okay, the first of the 3 months of the calendar. All right, so the third of the 3 months of the calendar. So we are saying that this is the first time that the sun is exactly overhead the equator. Okay, now when we say that the sun is exactly overhead the equator, uh, उसके बाद सन का मोशन होता है कि वो थोड़ा सा ऊपर चला जाता है कैंसर की तरफ, ओके, ट्रॉपिक ऑफ कैंसर की तरफ. सो फ्रॉम 21st March to 21st June, the sun tries to move. The sun's rays keep on falling at 90 degrees at various latitudes between the equator and the tropic of cancer, okay. So then the sun starts moving upwards to the tropic of cancer, reaches the tropic of cancer on 21st June, okay. That we term as the summer solstice, all right. Then the sun begins its downward motion to the equator once again, and the sun's rays start falling at 90 degrees at various latitudes, as in how you move towards the equator. Reaches the equator on September 23rd, which is termed as the autumnal equinox. Okay, and then the sun continues its motion downwards, and that is called as the finally, when it is overhead the Tropic of Capricorn on 22nd December, we call that as the winter solstice for the northern hemisphere. Okay. Okay. So once again, this is the, like we said, this is the track of the sun in a calendar year from March 21st to December 22nd. Okay, at various latitudes within the tropics. Please. Oh, Tropic of Capricorn. Sorry. Okay, so we are going from the Tropic of Cancer to Tropic of Capricorn in a calendar year. The sun moves across various latitudes, and we are saying that this is the motion. Okay. Now, when we say, please mark that the sun is exactly overhead only once on the Tropic of Cancer on June 21st, exactly overhead on the Tropic of Capricorn only once on the 22nd of December. Okay. And it is exactly overhead on the equator twice a year. So that would be March 21st and September 23rd. Okay. For all the rest of the latitudes also, the sun will be exactly overhead twice a year. Okay. For example, if you're considering the motion of the sun, say from this point. No, re baba, this one. Okay. So let's say we are tracking this particular point. Okay. Let's say we are trying to see when the sun is overhead at this point. So while the sun is moving from the equator towards the Tropic of Cancer, it will be overhead once at this point. Okay. This circle that we've marked. Okay. Even when the sun is moving from the Tropic of Cancer to the equator, it will be overhead once over here. Okay. Because it is coming down twice a year. So we are saying that at all the latitudes within the tropics, the sun will be overhead twice a year, including the equator. Okay. But on the Tropic of Cancer and on the Tropic of Capricorn, the sun will be overhead only once a year. All right. Okay. Is this? Somebody has. You guys don't switch on your. How do you say? Audio. There. Then we won't have an echo. Acha, you haven't joined. No problem then. Okay. Okay. Moving forward. All right. So now the next point is, after having understood this, let's see the importance of this. Okay. This is the importance of. Hope is it visible? थोड़ा सा अभी visible है, अच्छे से visible है. Okay. ठीक है. अभी वो apparent of motion of the sun का, how do you say, a more expansive view of it. Okay. Here we are looking at March 21st on the spring equinox. Can you see this particular figure? Okay. This is what we are looking at. The one. All right. Now look where the sun is. We say that on the spring equinox, the sun is exactly overhead the equator. Okay. Meaning sun के rays exactly equator को 90 degrees से hit करते हैं. Okay. Now जब वो sun के rays equator को 90 degrees से hit करते हैं, तो exactly half of the earth, exactly half of the earth has 12 hours of daylight, and the other half of the earth has 12 hours of night time. Okay. So this is throughout the earth, everywhere on the earth, you will have 12 hours of daylight and 12 hours of night time. Okay. This is the equinox. That is why it is called as equinox, equal nights. All right. That is the funda here. So we say exactly half the earth will have 12 hours of daylight. Exactly half of the other part will have 12 hours of night time. Okay. Everywhere on the earth. Then what happens is the sun starts moving towards the Tropic of Cancer. Okay. As in how the sun starts moving towards the Tropic of Cancer, the time of daylight in the northern hemisphere starts to increase. Okay. The daylight hours start to increase in the northern hemisphere. And when I'm saying daylight hours, just consider them daylight, the daylight hours in that sense, not the DST part. Okay. We are saying that the daylight hours start to increase as in how the sun moves towards the Tropic of Cancer in the northern hemisphere. Okay. Specifically for the northern hemisphere, daytime starts to increase. And finally, the peak of it is achieved on June 21st, when the sun sits atop the Tropic of Cancer. Okay. If the sun is exactly atop the Tropic of Cancer, this is what happens. See, the rays of the sun fall exactly overhead on the Tropic of Cancer, okay, which means 90 degrees से इसको hit किया. All right. Now look at the Arctic Circle, okay, Arctic Circle which lies at 66 degrees. That is also under complete daylight. Okay, look at the North Pole, that is also under complete daylight. Okay, look at the Antarctic Circle, it is in complete darkness, and so is the South Pole. Okay, so ये जो whiter section दिखाई दे रहा है ना, that is the one that is experiencing daylight. Okay, वो थोड़ा सा daylight experience करता है. वो जो grayish section है इस तरफ का, left hand side का जो grayish section है, experiencing nighttime. Okay, so what happens is that on 21st June, when the sun is exactly atop the Tropic of Cancer, Arctic Circle will experience 24 hours of daylight. The sun doesn't set that day on the Arctic Circle. Okay, land beyond the Arctic Circle comes to be called as the land of the midnight sun. Okay, and whereas the Antarctic Circle will remain in 24 hours of darkness because the sun will never rise there for an entire day. Okay, and so is the South Pole under darkness. All right, are we clear here? All right, okay. Moving on, the sun again starts its, like we discussed, that it has gone from the equator to the Tropic of Cancer. Now it will begin its downward motion, southward motion. Okay, so it will go from the sun's rays will start going overhead from the Tropic of Cancer towards the equator. Okay, and finally, the sun is again on the equator on September 23rd, which we call as the autumnal equinox. Okay. Once again, since the sun is exactly overhead the equator, all places in the world will get 12 hours of daylight and 12 hours of nighttime equinox. All right. Okay. And then it brings us to 22nd December, when the sun is exactly on the Tropic of Capricorn, overhead the Tropic of Capricorn. If the Tropic of Capricorn receives sun rays at 90 degrees, look what happens. It is closer. Now it is covering most part of the southern hemisphere. Okay. So Arctic Circle is in daylight, and so is the South Pole. But Antarctic Circle is in daylight, and so is the South Pole. But Arctic Circle is in darkness. Okay. So, and so is the North Pole. So this is what happens when the sun is exactly overhead the Tropic of Capricorn. Arctic Circle will experience 24 hours. Antarctic Circle will experience 24 hours of daylight, and the sun will not set here for an entire day. Whereas the Arctic Circle will experience 24 hours of nighttime. The sun won't rise for an entire day. Okay? Okay? Are we good here? Fine? All right. Now this is the varying lengths of day and night. Okay? So you have to understand that as and how you go upwards as in, away from the equator, the length of day and night keeps on increasing and decreasing depending upon the season. Okay, during summers, while the let's look at this. What do we call as summer in the northern hemisphere? When the heat clearly rises. Okay, the temperatures start to rise. All right, and you get more hours of daylight. Right now, what we call as summer is that time that we experience from, say, March to June. Okay, what is happening from March to June? The sun begins its advance from the equator towards the Tropic of Cancer. Okay, so while in the northern hemisphere, while the sun is going from the equator towards the Tropic of Cancer, the sun tends to give more heat or more energy or more, sun rays, direct sun rays in the northern hemisphere. Okay, and also for a longer duration. When you receive more energy from the sun or more sunshine from the sun for a longer duration, the Earth's atmosphere tends to heat up. Okay, the accumulated heat tends to increase the temperatures, thus giving you a nice summery feel. Okay, it is not nice everywhere, but summer is summer. All right, and this is how we experience summer in the northern hemisphere. All right, while the sun remains within the equator towards the Tropic of Cancer. Okay, the summer starts to decline from June 21st, sometime during mid-June or towards the end of June, because now the sun begins its progress or begins its track from the Tropic of Cancer towards the southern hemisphere. Okay, first it will go to the equator, and what we call as winter in the northern hemisphere is actually when the sun is now in the southern hemisphere. So the sun is way far away from us. Okay, and the sun's rays are always received in a slanting fashion. Okay, and for a lesser duration of time. If the sun's rays are received for a lesser duration of time and in a slanting fashion, we tend to accumulate less amount of heat. Okay, and thus the temperatures remain pretty low. So what we call that as is winter. Okay, and this is how because of the tilt of the earth, we get the apparent motion of the sun, and because of the apparent motion of the sun, we have varying lengths of day and night, and also seasons. Okay, so all of this is attributed, the fact that we have seasons, the fact that we have varying lengths of day and night, and the fact that we have an overhead sun at only certain places, all of this is attributed only to the tilt of the sun. Okay. Please remember the questions based on this are as simple as what causes the what causes the night or day in a on the earth, what causes seasons or the formation of a year, and why should I make it that way? Let's go here. I'm pretty sure we have something over here of that sort. Not this, not this. Let's see. Not even this. ये वाला अच्छा है. ये वाला आंसर कर सकते हो आप based on what we've just seen. Which one of the following cities of the world would represent the greatest linear velocity of rotation of the earth? Which city would have, or which let's forget about the cities. Tell me which part of the earth would experience the greatest rotation. सबसे ज्यादा rotational speed कहाँ होगा? इक्वेटर पे, है ना? इक्वेटर पे होगा. जैसे जैसे आप इक्वेटर से दूर चले जाते हो, स्पीड ऑफ रोटेशन ऑफ द अर्थ becomes lesser and lesser, becoming absolute zero at the poles. Okay, which of these cities lies closer to the equator? Kampala, Uganda, राइट. सेंट पीटर्सबर्ग, मैड्रिड या फिर स्टॉकहोम, ये जो सारे सिटीज है ये थोड़ा ऊपर है, ये तो डेफिनेटली टेम्परेट है. सेंट पीटर्सबर्ग एंड स्टॉकहोम. मैड्रिड इज ऑल्सो अ लिटिल अपवर्ड्स, है ना, थोड़ा सा मेडिटेरेनियन के ऊपर होगा, सो 35-40 के ऊपर ही होगा. कंपाला इज द वन दैट इज क्लोजेस्ट टू द इक्वेटर, बीइंग इन युगांडा, एंड दैट इज व्हाई दैट इज द सिटी. सी, दिस इज अ डेरिवेटिव sort of a question. Okay, this is not asking you direct facts. Nobody in this what you essentially need for this is two types of knowledge. One, to know that the equator will have the maximum speed, maximum rotational speed, and the second kind of knowledge that you require is placement of these cities. ये cities के locations का ये पता होना चाहिए. थोड़ा सा international world geography. Very correct. Okay. We have not. You might have done this, but we have not done this. Okay. ये वाला interesting question. ग्रुप डिस्कशन चल रहा था. आप तीन बच्चों ने 3 पॉइंट्स ऑफ व्यू बताए हैं. स्टूडेंट 1 says shape of the earth is basically an oblate spheroid. Okay. Student 2 says polar diameter of the earth is more than the equatorial diameter, and student 3 says that bulge along the equatorial region is due to the revolution of the earth. Which of these students are correct? पहले वाले को देखते हैं. ऑब्लेट स्फेरॉइड है क्या अर्थ का शेप? हाँ, है ना. हम ऑब्लेट स्फेरॉइड और ऑब्लेट एलिप्सॉइड, जियोइड ऐसे अलग अलग नाम से बुलाते हैं. तो पहला वाला बच्चा सही है. ओके. सेकेंड वाला, पोलर डायमीटर इज मोर देन द इक्वेटोरियल. विच डायमीटर इज ग्रेटर, इक्वेटोरियल और पोलर? इक्वेटोरियल बड़ा है, सो ये सेकेंड वाला बच्चा गलत है. सो आपके सारे ऑप्शंस में, सी वन वे ऑफ लुकिंग एट इट इज कि सारे तीनों ऑप्शंस में स्टूडेंट 2 मेंशन्ड है. So if you have already established that student 2 is wrong, तो you are left with only one option, student 1 is correct. Okay, समझा? ये options को देखिए, ये elimination का तरीका है. All right, लेकिन फिर भी for just ensuring कि आपका आंसर सही है, student 3 को भी statement देख लेते हैं. Bulge along the equatorial region is due to the revolution of the earth. Is it? No, it is due to the rotation of the earth. Earth rotate करता है, इसके लिए वो bulge है. Okay, इसके लिए वो centrifugal force and hence the bulge. All right, ठीक है. We've discussed this now. We had discussed this yesterday. Which one of the following hypothesis explains the origin of the universe? It is going to be the Big Bang. Okay, rest of the theories, nebular, binary or planetesimal hypothesis are origin of Earth. Absolutely correct. Okay, very good. This is the question that I was looking for. See, now this is something ideally you should have known in way back in 6th or 7th standard, right? So they are, no, but if you ask it in a different fashion, if you ask it in a more technical terms, then it feels like a difficult question. Okay, which of the following is or are environmental effects of the rotation of the earth? Daily or diurnal rhythm of daylight and air temperature. Okay, daily or diurnal rhythm as in, properly having 12 hours of daytime, or daytime and nighttime, and higher temperatures during the day, lower temperatures during the night, that sort of thing. Okay. So this of course occurs because of the rotation of the earth. First is definitely an option. Flow path of both air and water are turned consistently in a sideward direction. Sideward direction as in, let us say that, okay, let's say this is the earth. Okay, I'm not using a smart pen now. You must have figured that out. All right. And this is the equator. Okay. So now let's say there is an ocean current or a wind that is passing by. Okay. In the northern hemisphere. Now, even if that wind wants to pass in this direction, all right, this cannot be the direction for it. Wait. Oh, okay. Let's say this is the direction of the wind. Okay. This should be the direction of the wind. Let's say this is the direction. Okay. Ideally, northeast trade winds should have gone like this. Okay. But they do not go like this. Northeast trade winds do not travel in this fashion. They do not travel straight towards the equator. What they do is they are turned a little on the side. Okay. Northeast trade winds are turned a little on the side, and this is the way they travel. Okay. So they are turned towards the right in the northern hemisphere, and they are turned towards the left in the southern hemisphere. Okay, that is what we are saying. So we say that ये जो consistently sideward direction में flow करता है ना कोई भी freely moving fluid जो होगा, whether it is air or water, उसको constantly थोड़ा सा sideward direction में move करता है towards the right in the northern and towards the left in the southern hemisphere. तो ये जो motion होता है, that is because of the Coriolis force. Okay, because different latitudes अलग अलग rotation से move अलग अलग speed से rotate करते रहते हैं. Okay, तो जहां पर आपको डिफरेंस सबसे ज्यादा मिलेगा उतना कोरियोलिस फोर्स ज्यादा अवेलेबल होगा. ओके, तो इक्वेटर पे कोरियोलिस फोर्स ज्यादा होता नहीं है बिकॉज करेक्ट, क्योंकि आपको इक्वेटर के आसपास इतना डिफरेंस इन रोटेशन नहीं मिलता है, लेकिन पोल्स पे मैक्सिमम मिलता है क्योंकि डिफरेंस इन रोटेशन इज द मैक्सिमम देयर. ओके, सो कोरियोलिस फोर्स इज प्रोपोर्शनल टू द डिफरेंस बिटवीन द रोटेशनल स्पीड्स. इक्वेटर के बीच का एंड जहां कहीं आपका रेफरेंस लैटिट्यूड होगा उसके बीच जो रोटेशनल डिफरेंस है उसको प्रोपोर्शनल रहता है. अगर डिफरेंस ज्यादा है तो कोरियोलिस फोर्स भी ज्यादा है. तो इक्वेटर पे इतना टर्न नहीं करता है कोई फ्लूइड, लेकिन पोल्स पे सबसे ज्यादा टर्न करेगा बिकॉज कोरियोलिस फोर्स एक्सपीरियंस विल बी मैक्सिमम. ठीक है, चलेगा. तो दिस इज दैट टेक्निकल डेफिनेशन ऑफ कोरियोलिस फोर्स. फ्लो पाथ of both air and water are turned consistently in a sideward direction. You know what Coriolis force is. You know that fluids, any kind of fluid, whether it is water or air, will be turned in a sideward direction. You just didn't know you could put it in such technical terms, right? Agreed? And last is movement of tides. Ha and ha. Yes, rotation of earth पे ही depend करता है movement of tides. Tides क्या होते हैं यार? You are saying कि हाँ gravity की वजह से, you are saying कि sun and moon का जो मिलकर ग्रेविटेशनल ये पड़ता है उसका असर है टाइड्स. ओके, टाइड्स में क्या होता है, ओशन का जो पानी होता है वो कंसिस्टेंटली ऊपर राइज करते रहता है, फॉल करते रहता है. ओके, इट इज द राइज एंड फॉल ऑफ ओशन लेवल्स. ओके, ओशन वाटर लेवल्स. अब वो इसलिए होते हैं क्योंकि एट डिफरेंट अर्थ रोटेट करता है एंड इसीलिए डिफरेंट प्लेसेस को वो ग्रेविटेशनल पुल, सेंट्रीफ्यूगल पुल एक्सपीरियंस करने को मिलता है. ओके, सो वी आर सेइंग कि अगर वो अर्थ रोटेट नहीं करता तो हमेशा एक ही प्लेस को टाइड्स एक्सपीरियंस करने को मिलते हैं. ओके, दो जगह पे कॉन्स्टेंटली आपको हाई टाइड्स मिलते हैं एंड दो जगह पे आपको कॉन्स्टेंटली लो टाइड्स मिलते हैं. बट सिंस द अर्थ रोटेट्स एंड इसीलिए आपको हमेशा अलग अलग जगह पे टाइड्स एक्सपीरियंस करने को मिलते हैं, बोथ हाई एज वेल एज लो. ओके, सो ये जो है तीन पॉइंट्स आर एब्सोल्युटली करेक्ट व्हेन इट कम्स टू द रोटेशन ऑफ द अर्थ. ओके, दैट इज व्हाट वी आर सेइंग. आर वी गुड पीपल? ब्लैक होल किया था हमने कल. हाँ, लेकिन आप डिफाइन तो कर ही पाएंगे. वी हैड डिस्कस्ड व्हाट द लाइफ ऑफ द सन इज अर्लियर. तो वी वर डिस्कसिंग कि ब्लैक होल जो होता है, इट इज अ ह्यूज ब्लैक स्टार विच हैज जीरो एक्सेलरेशन. नो, करेक्ट, इट इज अ स्टार विच हैज कोलैप्स्ड ऑनटू इटसेल्फ. ब्लैक होल का फंडा ये होता है कि वो बहुत बड़ा होता है. वो जो ओरिजिनल स्टार था वो बहुत बड़ा होता है, मैसिव होता है, एंड बिकॉज ऑफ द मास उसका ग्रेविटेशनल अट्रैक्शन ज्यादा होता है. ओके, तो वो क्या करता है, वो जो ग्रेविटेशन, वो मास इट कीप्स फॉलिंग अमंग इटसेल्फ, कंडेंस होते रहता है, ज्यादा कॉम्पैक्ट होते रहता है, एंड देन वो बड़ा हो जाता है तो झट से अंदर चला जाता है.
फ्रैक्शन ऑफ सेकंड एक ही जगह पर बहुत ज्यादा ही बनने की वजह से वो ब्लैक होल बन जाएगा या कुछ नहीं.
Okay, cannot apply to all stars, but The funda is correct. The funda is correct. What Madhuram was trying to say is कि वो जो stars होते हैं वो during their life process बढ़ते जाते हैं का मतलब होगा कि उनका जो different gases का core होते रहता है ना वो expand करते जाएगा. Okay, so अंदर से खोखले होते जाएंगे. वो जो core होगा it will stop to include the hydrogen gases and instead कार्बन के कोर्स बनेंगे, हाइड्रोजन के शेल्स बनेंगे, so on so forth. Okay, and this is how the stars continue to expand. Okay, and then at a certain point of time जब उनका लाइफ साइकिल खत्म होने को है, लास्ट लाइफ स्टेज पे they will tend to collapse within itself very quickly, very rapidly. Okay, अगर मास ज्यादा होता है उस स्टार का जो अपने सन का नहीं है थैंकफुली, लेकिन इन केस ऑफ ब्लैक होल वील हैव टू कंसिडर दैट. ओके, अगर मैसिव होंगे वो स्टार्स बहुत ज्यादा, at least 1.4 times the mass of the sun, उससे ज्यादा या equal, तो फिर what happens is the star because of its extreme mass tends to collapse within itself. Okay, बहुत ज्यादा and बहुत rapidly collapse करता है and वो because of that extreme mass वो gravitational attraction and pull भी उतना ज्यादा होता है, right? So उसकी वजह से when the star collapses within itself and has a extremely large acceleration due to gravity on its surface, उसको कहेंगे black hole. The acceleration due to gravity is so huge कि कुछ तो हो गया, राइट? वापस द एक्सेलरेशन ड्यू टू ग्रेविटी इज सो ह्यूज दैट अल्टीमेटली वो जो स्टार होता है उसमें से लाइट भी एस्केप नहीं कर पाती इस डेड स्टार में से. ओके, एंड दैट इज टर्म्ड एज अ ब्लैक होल. ओके, उसको ब्लैक होल बुलाएंगे. चलो, this is the question that I was going for. Shortest day length that occurs in the northern hemisphere. नॉर्दर्न हेमिस्फीयर का शॉर्टेस्ट डे कौन सा होता है जिसको हम कहेंगे विंटर सोल्स्टिस, है ना? तो 22 दिसंबर. ओके, इतने अच्छे अच्छे क्वेश्चंस पूछते हैं आपको. कोरियोलिस इफेक्ट इज द रिजल्ट ऑफ प्रेशर ग्रेडियंट, अर्थ्स इंक्लिनेशन, रोटेशन ऑफ अर्थ. एब्सोल्युटली, सिर्फ एक छोटू सा आंसर, अर्थ्स रोटेशन. अगर आपको मल्टीपल आंसर्स चूज करने होंगे इसमें से तो अर्थ का टिल्ट भी कोरियोलिस इफेक्ट को कंट्रीब्यूट करता है? नहीं, नहीं करता. अर्थ के टिल्ट का एंड कोरियोलिस फोर्स का कोई इफेक्ट नहीं. हाँ, मतलब कोई वास्ता नहीं. कोरियोलिस इफेक्ट इज जस्ट बिकॉज ऑफ द रोटेशन. अर्थ रोटेट करता है, इसके लिए होता है वो. ओके, सोलर इक्लिप्स नहीं करवाना है, ये वाला स्टेटमेंट. सी, दिस इज व्हाट वी आर कंसीडरिंग. विच ऑफ द फॉलोइंग स्टेटमेंट्स इन द कॉन्टेक्स्ट ऑफ नॉर्दर्न हेमिस्फीयर इज आर करेक्ट? एंड मोस्टली हम नॉर्दर्न हेमिस्फीयर के हिसाब से देखते हैं बिकॉज हम नॉर्दर्न हेमिस्फीयर में रहते हैं. हमारा पढ़ाई एंड मोस्ट टेक्स्ट बुक्स ऑल्सो आर रिटन इन द नॉर्दर्न हेमिस्फीयर. ओके, वर्नल इक्विनॉक्स occurs on March 21st. हमने कहा था वर्नल इक्विनॉक्स इज स्प्रिंग इक्विनॉक्स, तो March 21st. यस. ओके, समर सोल्स्टिस ऑन December 22 in according to northern hemisphere. No, that is winter solstice. So ये वाला स्टेटमेंट गलत हो गया. ये वाला सही है, ये वाला नहीं है. ओके, ऑटमनल इक्विनॉक्स occurs on September 23rd. ऑटम इक्विनॉक्स, हाँ, ऑटम इक्विनॉक्स सितंबर 23rd को होता है. एब्सोल्युटली. एंड विंटर सोल्स्टिस 21st जून को. नो. ओके, सो वील जस्ट गो विद 1 and 3. ओके, समझा? फाइन. According to geoscientists, the shape of the earth is round, spherical, close to that of sphere or an oblate ellipsoid. चल यार, 4 तो होना चाहिए, है ना? तो वी आर सेइंग ये वाला ऑप्शन या ये वाला ऑप्शन डेफिनेटली कंसिडर करें. ओके,